This year's theme is Building Back Better, Harnessing Digitalization Towards a Transformed Philippines. And you are attending the EnergyEconomics session, natural gas, electric vehicles, forced outages, and forward markets. I am Mahalea Ravago, Associate Professor from the Ateneo de Manila University, Economics Department, and I am your organizer and session chair. Before I introduce all the speakers, let me just remind everyone of our house rules. We will let all the speakers finish their presentation first before we entertain questions. Zoom participants, kindly stay muted and stop sharing your video during the duration of the presentation. During Q&A, you may virtually raise your hand and wait to be acknowledged. You may unmute and show yourself when asking your questions. For participants on Facebook, please post your questions in the comment sections. For all participants asking their questions, do let us know your institutional affiliation. PES also requests that you accomplish an online evaluation form using this link. I will also type it in the chat box later. If you will be asking certificate of attendance, you can only have them if you accomplish this online evaluation form. Now, in this session, we will have four papers that will be presented. These are actually in various stages of completion. The first paper will be presented by Dr. Carl Robert Handok from the UP School of Economics and Professor Raul Favela, also from the UP School of Economics and National Academy of Science and Technology. The second paper will be presented by Rancy Prias, master's student at the UP School of Statistics, and J. Kathleen Magadia, who is currently a researcher at the Gas Policy and Development Project. I will be presenting the third paper, and the last but not the least paper will be presented by Paulo Lorenzo Tejano, who has just finished his MA from the University of Oxford. So each paper has a 15-minute presentation, and we will start with the first paper. So Carl and Raul, the virtual floor is yours. You're muted, Carl.
Thank you so much, Maha. I hope you can see my screen. It is a pleasure to present all of you this paper, which has been published in the journal Energy. At the outset, let me express my gratitude to all of my co-authors here, as well as to the DOE, PEZA, and the US State Department for partnering with us to make this study successful. Now, what really motivated us is the eventual depletion of Malampaya. Without any forthcoming discovery and exploration activities, the future of indigenous natural gas production is stark. But the consequence of this is clear for energy security. Natural gas plants accounts for 3,400 megawatts, or around 13% of installed capacity in the country. Without a replacement source, these assets will be stranded and future economic growth is jeopardized. We therefore need new sources of natural gas, either indigenously produced or through importation of liquefied natural gas or LNG. But of course, for a market of natural gas importation to develop, we need to go beyond its use in power generation. Creating this market, however, is complex and wicked. Okay? It's a wicked problem. What is needed is to create demand to make the needed investments, say pipelines and regasification facilities, to be economically viable. An obvious candidate would be requirements for certain energy-intensive manufacturing processes such as heating and boiling. In this regard, special economic zones, or SEZs, can play an important role in creating that needed demand. Due to their specialized facilities, technology, energy demand, and intensity, the potential benefits of natural gas use for firms located in special economic zones are greater than those outside SEZs. Currently, energy-intensive production processes such as that involves heating use diesel and LPG, which are dirtier than natural gas and more expensive to boot. Okay, so our objectives in this study is to gauge the extent of potential demand for natural gas use among SEZ firms, and we also want to determine the power and fuel use profile of these firms located in SEZs. So what we did is we did a survey of locators among manufacturing and agro-industrial zones. Our final sample consists of 115 firms located in 24 special economic zones. And our sample comprises around 7% of total firms in these zones, the manufacturing and agro-industrial zones. And as far as we know, the coverage of our sample is largest in recent studies involving SEZ firms. So here in this slide, it shows the firms in the SEZs that we have covered. As mentioned, we have surveyed 115 firms in 24 manufacturing and agricultural, agro-industrial SEZs. As you notice, the bulk of our sample comes from Luzon, specifically from the Calabarzon region. In our survey, we asked questions regarding company information, personnel, assets, and operations, as well as their energy sources, consumption and spending, as well as the types of fuel used for production. Now, specific to our study, we also asked questions on knowledge and perceptions on alternative fuels and their openness to switch their energy requirements towards these sources. So in this slide, we can see the components of the production processes that requires heating. So examples of this components include fabrication, welding, and molding. So firms that engage in this heat-intensive processes reported that their bulk of energy requirements are met with diesel, LPG, and electricity. Furthermore, we asked firms which fuel would likely be replaced by natural gas if it were made available. And most firms report that diesel and LPG and gasoline will be replaced in both production and backup power generation. So these fuels are, like I said, dirtier than natural gas, and therefore switching from these fuels to natural gas can have a beneficial and salutary effect to the environment. We also ask firms about their knowledge and perception about natural gas. In the top table, we can see, perhaps not surprisingly, that around 60% of our responded firms have little or limited knowledge of natural gas. Now, what is surprising is that despite this limited knowledge, majority of the respondents perceive natural gas to be safe, more than half of them, to be cost competitive, 65% said that natural gas is cost competitive, and 63% are even open to switching to natural gas if made available. Now, finally, what we did in this paper, apart from some other results, is that we did a logic regression as well as a linear probability model via OLS to determine which factors influence the probability of switching to natural gas. Of course, controlling for other firm characteristics. So in this table, we see that the belief that natural gas is cost competitive increases the probability of switching to natural gas. For instance, for firms with heating, those who believe that natural gas is cost competitive is higher by 39.4 percentage points. This is the difference, sorry about that. This is the difference between 76.5 here, 0.765, and 0.3371 over here. Now, compared with that increased probabilities compared to a firm with heating that does not believe that natural gas is cost competitive. And another result we have is that more knowledgeable firms here, look at these two numbers, have 10.2 percentage points higher predicted probability. So that's a difference between 0.769 and 0.578 over here of switching compared to firms that are less knowledgeable. So we also see that firms in private ecozones are more likely to switch compared to ecozones in public ecozones. Okay. Finally, firms who get their electricity from Meralco or other cooperatives have 13.5% percentage points lower predicted probability of switching than those who get their electricity supply from directly from other sources. Okay. So in conclusion, we find in this study that the biggest potentials for switching are those for firms who perceive that natural gas is cost competitive, those firms with advanced knowledge about natural gas, and those firms in private special economic zones. So therefore, increasing awareness about natural gas is crucial to convince firms to switch. We also find that switching to natural gas is less likely for firms whose energy requirements are supplied by Meralco or electric cooperatives. Therefore, in order to take advantage of natural gas salutary effect on the environment, it may be possible to increase natural gas use in the current energy mix. This is important because natural gas could play a crucial role in lowering aggregate carbon emissions. The good news is that the LNG industry is responding, and most of them are interested in making substantial investments to further develop the market. It is our hope that the appropriate regulation and industrial policy will be given immediate attention to push the industry forward. So thank you very much. I end here. I look forward to answering any questions later. I now turn you over to National Scientist Raul Fabella and enjoy the rest of the session.
Good afternoon, everyone. Good afternoon, everyone. The paper that we jointly co-authored is about natural gas and trying to raise the profile of natural gas, as well as the potential adoption of natural gas among our manufacturing firms. We have entered the era of COP26, and as you may have heard, COP26 cast a rather jaundiced view, of natural gas. And that is what we're going to talk about in some detail. Okay, so I asked the question, is natural gas a bridge? If natural gas is it a bridge to where? Is it to nowhere or to a low carbon economy eventually? Next, please. I'm going to set out a few facts about natural gas, which will circumscribe the discussion with respect to the embrace of natural gas as a bridge fuel. So fact one, natural gas emits about half the CO2 of anthracite coal, about 116 versus 228 pounds per million BTU of energy. So clearly there is a GHG footprint reduction with natural gas adoption and replacement. Fact two, natural gas consists mainly, however, of methane gas. With methane gas as a global warming potential of between 28 to 34 times that of CO2. So it is a powerful GHG. In fact, 1 kilogram of methane gas equals 84 kilograms of CO2. Fact three, natural gas consists mainly of methane gas. In fact, methanization is the process of converting natural gas to its useful form. Next, please. Fact four, comparable cost per kilowatt hour by fuel. Gas is about 6.5 cents per kilowatt hour for new gas plants, that is. We're talking about new plants. Coal is about between 5 and 17 cents per kilowatt hour. And solar, which is my favorite renewable, is between 3 to 6 cents per kilowatt hour as of recent auctions in East Asia. So clearly, solar now, at least the new plants, has a cost advantage against gas and coal. Fact 5, still gas is the fastest growing source of GHG emissions from fossil fuels, but that's probably because of the replacement of coal plants with gas plants, natural gas plants. On COP26 has declared virtual war on methane. Next, please. There are several movements that we have to be aware of in thinking about these issues after COP26. Movement 1, IPCC, which is in a report that was leaked to Guardian, is of the opinion that both coal and gas-fired power plants must close in the next decade to avoid climate breakdown. And that is, of course, the extreme vanguard of anti-gas fired plants, anti-gas thinking. Movement 2, ADB, energy transition mechanism, which was unveiled at COP26, called for the phase out of 10 coal plants, starting with 3 plants with a capacity of 967 megawatts or 1 gigawatt, and up to 5.9 gigawatts, about close to half of the gigawattage of the Philippine market. Eventually, of those 10 coal plants. Movement 3, clearly financing for coal will begin to cease. Surely there will be a shift to renewables and to natural gas. Next, please. There are, of course, valid questions, and there are no easy answers. And I am not about to answer them. I just am asking the questions and setting down the facts. There is a question of the lock-in problem. The new natural gas plants will have a half-life of perhaps 10 to 15 years and a full life of 25 years. And therefore, will it lock us into a fossil quagmire? Can we wait that long before the Armageddon, that is the 2 degrees centigrade limit, is reached? Finally, is natural gas a ruse to protect the fossil fuel industry? Perhaps to give it time to adapt. There is, of course, a valid issue in respect to renewables. And that issue is the intermittence issue, intermittence gap. Next, please. The intermittence gap is really the valid rationale for why natural gas may be a partner for renewables on the road to a low carbon economy. Well, there are people who will disagree. They will say that there are now grid scale batteries with 8 to 10 hours duration. Just to mention one, the liquid metal batteries or chemistries with 8 to 10 hours duration. That could cover essentially the whole nighttime. Grid scale batteries in place of natural gas peakers. That would probably be the most appropriate replacement for natural gas peaking plants. There was, of course, a great controversy with respect to ancillary services procured by the NGCP. And these ancillary services could easily be supplied by grid-scale batteries. And we now know that there are conglomerates who are interested in moving in a big way into grid-scale batteries. Lithium-ion batteries could also replace gas or bunker backup generators for commercial establishments. And that, of course, will also help. Next, please. We have to consider the choice environment. The Philippines has some of the highest share of renewables in the Asian region, 17%. But 10 years ago, it was actually about 30%. It has gone down now because of the emergence of new fossil-fired plants. And despite the entry of renewable solar PV ground-based renewables. The Philippines has a microscopic carbon footprint per capita compared to the rest of the world. And if I may say so, you may disagree with me, the Philippines cannot very soon replace 10 coal plants with renewables plus battery storage without huge economic disruptions and possibly also hunger. And that is troubling. For the Philippines, what is emerging is that natural gas may be a forced transition fuel, that whether we like it or not, our capacities dictate that for some, we have to adopt natural gas as a bridge fuel. I would like to say something about ramping up solar power supply. If we close the 3 plants that was suggested for closing by the ADB energy transition mechanism, we will need quickly about 1 gigawatt of power. Now, idle rooftop solar PV installations are by large commercial and industrial firms is a very, very low-lying fruit, which we should take advantage of. One way to do that is through a nudge which I call a contingent tax on idle rooftop solar PV installation. Tax on idle rooftop, sorry. An idle rooftop, a contingent tax on idle rooftop automatically gets lifted when 20% of the daytime power requirement of the firm or the establishment is applied in-house. My own back of the envelope calculation is that that will supply about 1 gigawatt of power. That is not enough to cover the 5 gigawatts needed if we have to close 5 or 6 of those or 10 of those coal plants. But that will be a great help, at least in the short run, at least in the closure of those 3 firms, 3 plants identified. This will be a new investment opportunity. Note that our big corporations were granted a bonanza, a 5% CIT reduction through CREATE. And the signal that is being shown here is that they will return it via tax if they do not use it to invest in, say, in solar. This 5% CIT reduction, which was argued to bring about a golden age of investment, has not done so. So maybe a nudge from the government of a contingent tax on idle rooftop would pump prime that kind of new era of investment. Thank you, and may affordable clean power be upon us.
Okay,
Thank you.
thanks. And now, Renzi, JCAT, the virtual floor is yours. Renzi, you might be muted.
JCAT, you're on mute.
Okay. Thank you, Dr. Rabago. Good afternoon.
JCAT?
Can you hear me?
Yes, yes, okay. JCAT, siguro turn off your video. Parang mababa. Okay.
Can you hear me?
You're lagging. Maybe turn off your video, JCAT. JCAT?
Now?
Okay. We can hear you now. Okay. Did she drop out? Renzi, what happened to JCAT?
She's still here, ma'am.
Okay.
Can you hear me now?
Yes, okay, now.
Hello?
Yes, okay, JCAT.
Can you
Continue.
hear me now?
Yes.
I'm so
Yes.
sorry about that. Okay, good afternoon, everyone. I'm JCAT Magadia. I'll be our paper alongside Mr. Renzi Frias. We've written this paper alongside Dr. Mahalea Rabago, who served as our lead author. So our presentation is divided to provide some context. And later on, Renzi will take over to get the EV industry in the global scenario. That the EV uptake has grown significantly, with the global electric car fleet exceeding 5 million in 2018 and reaching up to 9 million in That's almost double the amount of new electric cars. But despite this notable growth of 2.3 million units on the road, that's about 45% of running.
JCAT? Okay, we're having some Technical
Connection problems.
difficulties. Connection issues. JCat, we keep on losing you. Maybe turn off your video. Renzi, can you share na lang siguro para nasa-save kay JCat? And then you're now muted, JCat. So turn off your video, JCat. I think we lost JCat na, Renzi. Can you continue?
Hello. Hello.
Renzi, you just share. Okay, you may continue na lang, Renzi. I think we lost JCat.
I'm here.
Okay.
I'm not sure how. Hold on.
Okay, sige.
Okay, I'll just turn off my cam, and
Yeah.
I hope it will go smoothly from here now on. Okay, so here we see Vietnam and Thailand. We've highlighted them because they are considered as the first movers in the ASEAN region when it comes to electric vehicles. So we see here, Thailand boasts an EV stock of around 600 units for light four-wheelers in 2018. This does not include the electric two and three-wheelers, which are in the thousands. Then in Vietnam, it reached an estimated amount of 2.5 million units of e-motorcycles, which is poised to replace the mass of motorcycles in the country. So these figures, though they may seem a lot, may be sort of deceiving in relation to the total EV stock density or market share. So see, we see here that although China recorded the highest EV stock in the world, as shown in the previous slide, it is lagging in terms of market share at only 4.48%, meaning less than 5% of the cars in China are actually electric vehicles. This shows that EV market in China is still relatively marginalized when compared to the entire car market of the country. The same goes with US and Japan. Meanwhile, Norway, which was trailing behind China, US, and Japan in terms of number of units, actually has the highest EV market share, with 46% of their entire car market being composed of electric vehicles. So their market share is actually 10 times that of China. One factor that contributes to the EV market share is the per capita income of the country. See here, Norway, with the highest income per capita, also has the highest EV stock density, with 47 electric vehicles associated to 1,000 individuals. This graph shows that people in countries with higher income tend to purchase more electric vehicles, basically because they have the means to do so. Therefore, the higher per capita income, the higher the ratio of electric vehicles. Apart from higher per capita income, government policies and incentives spur the development and adoption of EV among the global leaders. So in the interest of time, I'm just gonna browse over these policies. So here we have the policy instruments targeting the supply side of the market, such as import tax incentives and other manufacturer incentives. These are put in place to attract more investors into the EV market and encourage producers to further develop and improve their EV offerings. Well, here we have the incentives for the demand side. We have exceptions on purchase tax and vehicle registration taxes. There are also reducing upfront costs and bridging cost gaps with their internal combustion engine counterparts. Then here we see the non-financial incentives. So per capita income and government policies and incentives are just two factors affecting adoption when we talk about the country scenario. But there are also factors that affect the consumer level, and these are shown here. There are internal and external factors. So these may be, a lot of these may look like hurdles to adoption, but depending on the speed of technological development and degree of competition in the market, these major impediments to EV adoption may be overcome. So what exactly is the state of EV adoption in the developing countries? The penetration of electric vehicles is not as fast in developing countries, primarily because of the prohibitive upfront purchase cost of the units. But in recent years, the technology has been extended and adopted to local settings, such as in two-wheelers, tuk-tuks, e-trikes, e-scooters, among others, making it viable and relatively affordable to consumers in developing countries. In the Philippines, light-duty electric vehicles is only 6% of the country's EV stock. That is 153 units to be exact. The majority of the registered EVs are two-wheelers and three-wheelers, wherein 38% are e-motorcycles and 56% are e-trikes. So in terms of density of EV per population, with only 2,525 EV units, we can see how rare EVs are in the country, and we all know that. But the Philippines is now moving towards crafting the national policy and legal framework to promote electric vehicles, which is the motivation behind writing this paper. So why promote electric vehicles in the country? So first, it can help reduce local air pollution, greenhouse gas emissions, and vehicular noise. And two, it can reduce congestion, especially when regular car users opt for e-bikes or e-motorcycles for short distance trips. So in which sector do we propose to promote EV adoption in the Philippines? This part will be discussed by Renzi.
After presenting the case for the promotion of EV adoption in the country, the question now is where to start. In the Philippines, incentivizing private use only benefits high-income consumers, which does not guarantee total replacement of existing combustion vehicles, thus defeating the purpose or the environmental objective of EV use. Common in developing countries like Vietnam and Thailand are electric two-wheelers. This is possible in the country given the relative affordability and the expanding logistics industry. However, the current battery capacity limits substitutability. Also, electric two-wheelers are still not permitted in major thoroughfares. Given all this, a more promising candidate is to start with public transportation vehicles where jeepneys are the most popular. So why e-jeepneys? First is the equity reason. Jeepney operation is a major source of income and employment for the lower income households and also to the dependent businesses. However, private investment is unviable and prohibitively costly without external assistance, even for the middle class. Second is that investing in e-jeepneys provides better opportunities for transport operators and drivers, given that the overall benefits and structure that go with the modernization program. Third is that it is safer for the riding public because e-jeepneys are compliant with the Philippine national standards on vehicle safety features. Lastly, e-jeepneys provide huge benefits from a social perspective in terms of avoided environmental and health damages and their contribution to energy security, as we will be seeing later on. The framework of the study involves evaluating EV adoption from the society's perspective through a cost-benefit analysis. Given that jeepneys are public goods, it is only reasonable to push for the transition only if the socioeconomic net benefits are positive. Specifically, we will be comparing the ownership of e-jeepneys relative to traditional diesel jeepneys for a period of 10 years. We present here 4 scenarios. In the first or baseline scenario, we account for the current generation mix of the country. For the second scenario, we incorporate the technological advancements as reflected in the falling battery prices. Third, we consider the transition to cleaner energy as illustrated by the falling prices of solar and other renewable energies. And assuming market signals work, this also means an increased share of solar and other REs in the generation mix, and also a decrease in the share of coal and reduction in environmental and health damages. Lastly, we consider sourcing 2/3 of the electricity requirement of EVs from a grid-tie solar-powered charging station. Now, to facilitate comparability, we have set up various specifications and assumptions. The recurring assumptions in the analysis are both diesel and e-jeepney are assumed to travel an average of 100 kilometers per day and operate for 312 days per year. The derived costs and benefits are incurred and realized respectively for a period of 10 years and are in current 2019 Philippine prices. We also would like to point out that we do not aim to make any forecasts here, and we understand that the data on this topic are constantly changing, and we are working with the best available information at the moment. For the first benefit, we compute for the 10-year fuel or power requirement of each jeepney, given that a traditional diesel jeepney runs 6 kilometers using a liter of diesel, while an e-jeepney runs 90 kilometers using 18 kilowatt hours of electricity. Multiplying the values in the first row to the current price of diesel and electricity, we get the highlighted fuel savings. Second benefit, we calculate for the avoided operations and maintenance costs of e-jeepneys. As we can see here, the benefits come from the lack of necessity for an oil change and spark plug replacement for e-jeepneys. Third benefit is the avoided environmental costs. Using information on the carbon costs of burning of diesel by a traditional jeepney and burning of coal from generating electricity used by an electric jeepney, we compare their 10-year carbon emissions cost. Here we use 54.6% as the share of coal in the generation mix. Since the carbon damage data used are in current 2017 prices, we incorporate an inflation factor to pump prices to 2019 values. Now we look at the avoided health damages due to the reduction of criteria air pollutants. To calculate the health damages of a diesel jeepney, we multiply the amount of local pollutant emitted per kilometer traveled with the damage cost per metric ton of the produced pollutant from diesel burning. For the e-jeepney, like what we did in the third benefit, we consider the associated health damages per local pollutant produced from burning coal for power generation. The fifth benefit is the energy security premium associated with the displacement of diesel by electricity. While the impact of an oil supply shock has been found to be short-term in nature, studies suggest that defensive mechanisms should still be put in place to mitigate adverse inflationary effects. Also, diesel displacement creates a positive externality that should be counted as a social benefit. Hence, we quantify here the energy security premium per liter of diesel. Then we downscale the available information for the US using the ratio of per capita GDPs, which takes into account the relative size of our economy to the US and reflects the differential effect of an oil supply shock. Other potential benefits of e-jeepney adoption are described in this slide. In the interest of time, I will not be going over this. As for the costs, we consider three. First, the retail prices. Second, the cost of installing a level 2 charging station at home, which we assume to be compatible with the type of e-jeepney in our analysis. And lastly, we account for the subsidy provided by the government under the DOTR's modernization program to traditional operators and drivers for switching to modernized jeepneys. Compiling all the benefits and deducting all the costs, we see here that in 10 years, switching to e-jeepneys can achieve an aggregate of 1.2 million pesos in terms of net social benefits and in nominal terms. It is worth noting that the bulk of the benefits come from the fuel savings and bulk of the costs come from the vehicle purchase. We also compute for the annual present value costs and benefits over the 10-year period using the 10% social discount rate of NEDA. We can see here that the benefits are greatest under the falling battery price scenario or scenario B and least under the social power scenario or scenario D. Further analysis also reveals that initial capital will be recovered on the 5th year under all scenarios except under scenario D where break-even occurs on the 6th year. A sensitivity analysis using a lower social discount rate of 7.4% shows that the trend of rate of returns is still the same. Our results show that in all scenarios, the net benefits of EGP adoption are positive and the rates of return are favorable in 10 years, which point us to several policy implications. As for scenario B, it highlights the importance of supporting the development and manufacturing of domestic e-jeepneys and other EVs to eventually drive down investment costs. Scenario C, on the other hand, highlights the potential viability of e-jeepneys given the power mix in developing countries. As seen in the relative rate of return, EVs are more beneficial when fuel mix is composed of largely clean renewables. However, it must be noted that this does not warrant renewable mandates and subsidies that contradict the affordability, reliability, and security objectives of the EPIRA and the Tax Reform Act. Moreover, the COVID-19 pandemic presents an opportunity for an efficient transition to cleaner energy, given the lower electricity demand associated with the lower economic growth trajectory. Efficient energy transition should also consider the declining costs of wind and solar power and the low costs of managing intermittency at levels needed to meet the renewable portfolio standards. As for scenario D, although the BCR is still greater than 1, the lower net benefits result from the current high cost of installing a grid-tied solar charging system. As solar panel technology is accelerating very fast, it will not take much time until the system catches up. So for our concluding remarks, given the positive net benefits in the analysis, intensified public awareness campaign is justified to stimulate acceptance among the wider stakeholders, including the operators, drivers, and the riding public. Moreover, an EV roadmap starting with jeepneys, followed by other transportation vehicles, has the greater potential to successfully develop and nurture the industry. Lastly, despite being instrumental to EV adoption, incentives must be carefully studied and must only be in effect for a specific period, just long enough to put EVs in the mainstream, but not too long to put burden on public finances. That's it, and thank you very much. Over to you, Dr. Ravago.
All right, thank you, Rancy. So I'll be now presenting the third paper. Okay. So the third paper is titled Reliability and Forced Outages Using Survival Analysis with Recurrent Events. So this is a work in progress with Carl Handok and Mia May Pormon. As context and introduction, reliability together with accessibility and affordability makes up the three dimension of energy security. At the firm level, it's in their best interest to ensure reliability of their power plants because it affects their sales and consequently their profit. But nonetheless, declaration of forced outages may be used as a tool to exercise market power by withholding capacity, thereby increasing spot prices. For several years now, we've been experiencing brownouts and blackouts. This actually started in 2016. And initially, it was the May 2016 election that was blamed for the Luzon power. Then year after that, we've been still experiencing these brownouts. And the regulatory and policy agencies like DOE, ERC, and PCC are now probing into this alleged coordinated shutdown or collusive acts. Now, what really happened in 2016? So this graph shows you the 1 month period from July 15 to August 15, 2016, where we have this problematic period where we see the net supply. This is in Luzon, going down to the negative region, concomitant with the peaking or increase in outage capacity. That's the orange line here. Consequently, the average spot prices have increased. No? So in this period of July 25 to August 5. Now, reliability at the plant system affects the integrity and reliability of the entire system. So at the plant level, duration of forced and planned outages is seen as an reliability indicator. So this is where our interest is in. So we asked what determines reliability of power plants given their characteristics. We will be using the data from January 15 to January 2018, so in the period of 3 years, and we collapse the outages into forced and planned outages. So we have a total outage incidence of 6,646. Okay, now what are the typical reasons for these declared forced outages? So we can see here the reported reasons would be line tripping, hardware repairs, and even natural disasters. Now, before we go into the formal analysis of what determines reliability of power plants, let me just go through some descriptive statistics so that we may have a sense of what the data is. We already saw that during the problematic period, that 1 month period, there is an increase in outage incidents. Another variable of interest that we are looking at is this number of days since the last maintenance of the plant. We take this as proxy for preventive maintenance. So an ideal indicator would be the cost of prevention, no? But since we don't have that, we just take the number of days from its last maintenance as proxy to preventive maintenance. Now, the failure of power plants is also related to their age, and the literature has established that this follows a bathtub curve because failure is potentially higher both during the early years and later years of the plant. In the early years, this may be where faulty units are being replaced, and in the latter period, we see degradation and wear and tear. We see that the distribution, this is over in Luzon and Visayas, there are relatively more younger power plants here, both in Luzon and in the Visayas. So these are mostly the variable renewable energy because these are the recent investments. Geothermal is the oldest, which is about 25 years. Natural gas is about 17 years, and hydropower about 15, and coal average about 13 years. We are also interested in the reserve margin of the system. The mean reserve during the problem period is very thin, as we can see here, with a minimum of near zero and maximum of 30%. So when I say the problem period, this is that 1 month period that I showed earlier, and the entire period is over the 3 year from 2015 to 2018. Now, we now go to the formal analysis of answering what determines reliability of power plants using survival analysis with recurrent events. The event of interest here is outage, the forced outage. Typically, in the survival analysis, it only uses the time to event, meaning the time to outage. But the type of analysis that we're implementing is recurrent to time event, so that all the succeeding events, or in this case, outages, is included in the analysis. Now, for the students, you may recognize this. If this is the period of study, plant 1 and plant 4 are the right sensor data, and plant 2 and plant 3 are observations that drop even before the study period has ended. This is okay as long as the reasons for their dropping off are not related to the event of interest, which is outage. Now, in implementing this analysis, we use the proportional hazard model by Cox, developed in 1972, which gives the hazard. This is the hazard, and this is the forced outage at time t for the generating unit given its characteristics x. So that's the vector of characteristics. Then this term here, the first term is the baseline hazard function, and it's only a function of t and not the characteristics of the unit. So meaning all plants faces the same baseline hazard function. And then the second term here, this is what we call the relative risk, which is the proportionate increase or decrease in risk associated with the set of characteristics of the plant. So thus, all plants would be facing the same baseline hazard function. And then beta here would be our coefficient or the hazard ratio estimates that we are interested in. Now, Anderson and Hill generalizes the Cox model, which is formulated in terms of increment in the number of events along the timeline. So meaning now we take into account all the events after the first event, which is outage. The basic assumption is that it has a random hazard intensity process, so that the hazard or the estimating equation becomes this because it takes into account all the events or the outages. So in our analysis, the duration between outages is our measure of plant's reliability. And the characteristics used, or the vector of characteristics used, is the planned outages. That's the number of days of maintenance. This is the preventive maintenance that we discussed earlier, number of days since last maintenance of the power plant. The use rate, which is just the ratio of dependable over the installed capacity, the age of the power plant, and the square of age of the power plant, reflecting the bathtub curve that follows the relationship between age and failure of a plant, reserve margin, the owner share capacity, and the power plant dummy, so meaning the 10 types of power plant technology. Now, this is our results. So the numbers that are shown here are the hazard ratio. So since this is the hazard, so this is 93, we interpret it on the flip side, which is the reliability of that of the plant. So for example, the hazard ratio for the days since last maintenance, or the preventive maintenance. So we interpret this as the higher the number of days since last maintenance would lead to a unit having a reduction of 3% on the risk of outage. So it's just 1 minus the hazard ratio. And for the age, we see here that it's also significant. The older the power plant, this lead to units having a reduction of 3% on the risk of outage. But we note that the age of square, its coefficient is 1, so that as the unit gets older, we see that the effect is neutral following the bathtub curve. What's also interesting here is this is the hazard ratio on the reserve margin. So we see here that it's very small, so that we interpret this as that the higher the reserve margin leads to unit having a reduction of about 94% on the risk of outage. Okay, so the results are intuitive. And then we also have we put also the binary indicator for the type of plant. Another interesting results that we see is when we compare the predicted versus the observed survival curves. So we focus on the relationship between the preventive maintenance as represented by the variable days since last maintained and forced outages. So we group the power plants into quartiles, with the fourth quartile having the highest number of days since last maintenance. So this may be small, but this is the last quartile. So in this case, we see a deviation of the observed. This is the observed, and this is the predicted. So this points out that there may be other things that explains the increase in outages that we saw in the data. We find that the higher the number of days since last maintenance, the older the power plant units, the higher the reserve margin, and even share capacity lead to a reduction of the risk of outage. The type of technology also matters. Relative to coal power plant units, the other type of power plants lead to an increase in the risk outage. We also find no economic and statistical difference between the periods before and after. So going back to the result, we have estimates for the entire period, before the problem period, and during and after the problem period. So we find no statistical difference between these two periods. This points out to the absence of a systematic difference between the contributory factors of the outages during the problem period and all other incidents of forced outages. That is, factors that contribute to forced outages are relatively the same across the period of our study. But nonetheless, this does not mean that the this does not mean that we don't that the empirical exercise our empirical exercise in this paper can still serve as a guide for external plant auditors and regulators in investigating unwarranted force outages. In all other jurisdictions, the regulators of electricity industry bears the burden of proof to bring alleged abuse of market power to a case. But how can this be mitigated? We see that in other jurisdictions, it has been observed that the efficient performance of a wholesale market is positively associated with the extent of the data that is released to the public. So the Philippines can learn from best practices in other jurisdictions. Let me briefly report the outage protocols that we have here in the Philippines. The reports are confined only to the ERC, NGCP, and the DOE. Forced outages reporting of the generation company is taken by both the system and market operator in good faith. No immediate audit is conducted to verify whether the forced outage is indeed a forced outage and not just an instrument to withhold capacity. In New Zealand, Australia, and the US, information are available in the website in which the public can access details about the outage. Other generators were also provided of the information or notices to check the status of their power system. The reporting protocols differ in the amount and type of data made available to the public and the length of time the data is created and released to the public. An example is in this Australian interface. You'll see all the information in their website. So as concluding remarks, it is common knowledge that the Philippines historically has very thin reserves. Not unlikely that the generation companies take this into account when formulating their strategic decisions in the wholesale spot market and use forced outages to exert their market power. Immediate technical audit to verify forced outage report is prohibitively costly. Thus, outage report are taken as is. Jurisdictions from around the world are finding ways to establish clear and transparent rules in reporting timely releases of reported data on outages. The Philippines can learn from these best practices of sunshine regulation in terms of outage reporting and protocol. Sunshine regulation means transparent reporting. In the long run, opening additional windows of competition can help mitigate the abuse of market power. Having a formal, active market in lieu of bilateral contract can potentially help increase competition even with a concentrated generation market. And this is the topic of the next presentation by Tej. Thank you very much. So Tej.
Okay, thank you, Mama. Good afternoon, everybody. And it's very nice to be here at the press conference. So this is a study that we've been working on for the past almost 2 years, actually. And as many of your work, I assume, has also been derailed by the pandemic, ours was too. But we're very, very happy to finally now have the opportunity to present some preliminary results from this very interesting study. And it is a work in progress. And so we're very interested to gather your thoughts, your insights, and your comments on this study, competition in electricity forward markets. So we designed a laboratory experiment in aid of improving market design in the Philippines, working with Dr. Handok, Dr. Bing Radok of the PCC, and Dr. Ravago. So why are we doing this? Why are we doing this study? Well, first line, something that almost everyone, I guess, who's joining this session would probably know. 20 years after EPIRA, the Philippines still has the highest electricity rates in Southeast Asia. But there are some interesting policy developments in this space. We know that the IMOP has been working with the DOE and the SEC and some generation companies to study the development of forward market for electricity in the Philippines, as this is already something that is being done in many different jurisdictions. And so there is the prospect for a more transparent and centralized forward market that could actually potentially be the replacement for the current system of bilateral contracts, which continues to dominate the majority of electricity purchases from DUs by DU, from generators. And so this is obviously a big policy development if it will happen. And so, we want to understand what could the effects of such a forward market, the creation of such a forward market be. Can it have the potential to actually lower prices and increase market efficiency? So there have been a couple of different studies on forward markets in electricity done in different jurisdictions. And what our experiment tries to do is to add a couple of market design elements, I guess you could call it that, that would suit or be more aligned with the Philippine case and allow us to gain a better insight of what effect this might have on our own electricity markets. First of all, we determine the number of dominant market players in this experiment endogenously. More on that later. We also include a must-offer rule, or the mandatory offering of one's full production capacity, as those of you who have studied the WESM will know that this is a rule that is present in the WESM. And so we try to approximate some of these market design features. We try to innovate a little bit and ask some further questions as well. What would short selling do? And so we tried to incorporate an element of short selling in this experiment as well, to assess what that could do to the creation of a forward market. And we also try to mirror some element of long-term contracting. We know that bilateral contracts are very often longer term. And so we wanted to gain an insight as to how this could be implemented, for example, and what the effects might be in the forward market. And there are some very interesting results, as you will see later on. And so there's a mechanism to lock in certain price for some multiple periods in this experiment. Basically what we try to do is mimic a typical electricity market and do it twice, right? Do it once for the forward market and do it for the spot market. As I think a lot of you also understand how an electricity spot market is priced, and where you have the offers of price and quantity made by different generators or different agents, stacked one on top of the other in order of price, and the highest price at the point, the price at the point where supply meets demand becomes our clearing price. And so essentially what we're doing is we do one of this for the forward market, where agents will offer in this stage price and quantity in the forward market. If they satisfy demand, then we will have at that point the clearing price. Any residual capacity will then be what is left for them to trade in the spot market. So this is basically what our model for the experiment is. So how do we implement in the experiment? How is it designed? And I think this is where it becomes really interesting and to see how agents and players interact with one another. So we conducted an online experiment between subjects. So each participant played the role of a seller, competing on the price of a homogeneous good. So in each group of 5 sellers, so there is a group, and in each group there are 5 sellers, there was a total endowment of a homogeneous good. In our experiment, we basically called this homogeneous good trinkets. And so there's a total of 5,000 as a quantity to be split among the sellers in this group. Now, the allocation of that would be determined, or was determined, by a one-time arithmetic contest within the group. So at the start of the experiment, 5 participants played a short arithmetic contest, essentially solving some quick mathematic problems. And based on their performance, that would determine how much of the share of the 5,000 trinkets they would get. And I'll explain the different treatments under which there were some provisions for players to be given a larger amount, or others to be given smaller amounts as well. Now, on the demand side, so the total demand per round was variable. So the experiment was played over a series of rounds, multiple rounds, up to 40 rounds. And the demand was variable between 3,000 and 5,000. Now the participants knew the range of this demand, and so it was clear that not all the quantities could be sold. In almost all the rounds, basically, not all quantities would be sold, and so this is basically how it was structured. So we ran 5 treatment groups under these conditions, and I'll go through them one by one. So we have 2 experiment conditions that have a spot market only aspect to them, and 3 that include both a spot and a forward. And in the spot market only conditions, there is one which does have the must offer rule. Basically, there is one stage, and we call that the real-time stage. And in that stage, you have players basically only entering price information, price offers, as their quantity must all be offered. And so whatever their capacity allocation was, that would be offered in the market, and all they have to do is enter the price. Now, there's another treatment under this spot only group, and where we allowed capacity withholding. Basically, participants were free to determine the quantity that they want to offer and then the price. So they enter the quantity and price that they want to offer. And obviously this makes a difference. You'll see later on in the results. And then we have 3 types of forward market treatments. So the first one, so you have a spot and a forward. We call, as I said earlier, we call the spot trading stage, the real-time stage, and the trading stage incorporating the forward market. We label it in the experiment the period ahead stage, where you, as a participant, will enter your price and quantity offers for future stages, depending on the parameters or the design of that particular treatment. And so there's a basic, the third row here, there's a basic forward market structure. And so here we have your typical spot, but we also include the simplest form of the forward market, and which has a must offer rule as well. So whatever amount you offer, so you're free to choose the amount that you offer, the quantity that you offer in the period ahead stage, and whatever is not sold is your residual capacity. That residual capacity will all be offered in the real-time stage, in the succeeding real-time stage. And then the fourth row, where we try to incorporate short selling. And so basically, this is similar, except so you have both the real-time and period ahead stages, except here, as a participant, you can actually offer beyond your capacity in the period ahead stage. So let's say you have 100 or 1,000. You can offer more than that. And basically following the concept of short selling, what you are offering beyond, when you're offering beyond your capacity, the shortfall, you will have to purchase in the real-time stage. So this is sort of an innovation that was a bit complex to design, but we tried to do it, and I think it also yielded some interesting results. And then finally, we tried to mimic some longer-term contracting, wherein we included a 5-period lock-in. So this last forward market treatment is basically similar to the simplest forward market treatment, except that your offers in the period ahead stage will basically be locked in for 5 periods. And so you can only change your forward market offers every 5 periods instead of every period. So, and then there is a must offer rule as well that is incorporated here. So players could offer what we call in the game the experimental money for the currency of the game. An experimental money from 1 to 100 is the price that they could offer. And for each of the conditions, we ran it with 0, 1, and 2 dominant players. Now, I remember I mentioned something about the arithmetic contest earlier. So in a treatment that, for example, had 0 dominant players, regardless of the result of the arithmetic contest, they would have the same capacity. So let's say 1,000 each if there was 5,000. Now, in a treatment where there was one dominant player, the winner of that arithmetic contest would not be known to the group, but that person would basically have the greatest share of the capacity. And in two dominant players, you'd have two who are equally large, and the rest of the participants, the three others, would have the smaller capacities. So some preliminary results. First interesting result that we found, in treatments with a forward market, a larger share of the trades occurred in the period ahead stage. So this actually runs counter to some expectations. As we were going over the literature, a lot of the expectations and predictions showed that the bulk of the trading would still occur in the real time, and that players may minimize their activity in the forward market. So this is something that we saw that was very pronounced, as you can see from this simple chart. In all three of the treatments that had the forward markets, you had a greater share, a much greater share of the capacity being offered in the period ahead stage, and the residual was remarkably smaller than what was being offered in the period ahead stage. Now, just a note as well that the numbers are not additive. And this is because if you take a look at, for example, the must offer, the leftmost group, everything that is offered, and this is at the group level, this is the capacity offered aggregate of the 5 players in the group. And so not everything that is offered will be sold. And so the residuals may vary, and that those residuals will be the ones offered in the real-time stage. But still, if we look at it, we see that basically on average, the groups are offering 83% of their capacity already in the forward market, wanting to commit it in advance and leaving only this minimal amount. In the short selling, you see that there is really an appetite to short sell, basically offering way more than 100%, right? So 127%. And then the residuals that are being offered in the real-time stage are just roughly 26%. 5-period lock-in shows a little bit more muted difference, but this difference nonetheless, nearly 2-to-1 basically. But you see this consistent across the 3 treatment groups with forward markets. Result 2, prices. So 2 sub-results here in the prices section. First one, the average clearing price per group in the real-time stage is significantly lower than in the period ahead stage. So we take the treatment with the 5-period lock-in condition and visualize the prices over the course of the game. So I'll show you this treatment in the interest of time, but basically across the 3 treatment groups that had forward markets, we see similar patterns. But just to visualize, we'll take the 5-period lock-in because here is where it's visually much more pronounced. Basically, what we see is that the prices in the real-time stages are much lower than the prices in the period ahead stages. And so, this is basically similar across the 2 other treatment groups, as I mentioned. So this is another interesting result. Basically, if we compared real-time clearing prices for treatments without forward markets, as you will see in the second result, those with forward markets had much lower clearing prices as well. So the second part of this result of clearing prices, basically we found that among treatments with a forward market, the 5-period lock-in condition yielded the lowest real-time clearing prices. So here's a table that you might appreciate and gives you sort of a better picture of what kind of clearing prices we saw. So we're comparing real-time stage clearing prices here. Highest prices consistently across the board, no forward market, spot only, withholding allowed. So that's something to take note of. Must offer rule, spot only, actually performed quite well relatively. I say quite well, I mean that the prices were quite low compared to the other treatments. But the most notable result here is the bottom row, wherein you have in the 5-period lock-in your real-time stage prices, whether it was overall or no dominant players or one dominant player or two dominant players, you found consistently the lowest real-time clearing prices with this 5-period lock-in in the forward market. So note that if we work on the assumption that the forward markets, if implemented, has the potential to replace bilateral contracts as a more transparent way of doing forward transactions. It's very difficult to look at the period ahead prices and say whether it's high or low, because the true comparison for that would be period ahead prices versus bilateral contract prices, which we do not have. But what we're looking at is real-time clearing prices now. This would be your spot market clearing prices. If you implemented a forward market with 5-period lock-in, it seems like this kind of condition produces, among our treatments, the lowest clearing prices. So again, as I said, preliminary results, there are a lot of interesting things that we found, and we plan to dig deeper, basically. We've identified a few other things to examine. First, we want to understand who's driving the price moves. We'll try to study the trading behavior of larger and smaller players, analyzing offers and earnings of these dominant players and comparing these as well to the smaller players. We also plan to take a closer look at the short selling strategies and how players behave there. As we saw, there was this appetite to actually use that and take advantage of the capability to short sell. We saw these 127% of capacity average offers in period ahead stages for short selling. And so we want to understand how players behaved in this short selling. And we also think that there is an interesting case to be made about some learning over time. We noticed a slightly upward trends towards the latter rounds visually, and some convergence as well. We need to dig deeper in this. We did play 5 practice rounds at the start of the experiment before actually playing the actual rounds. But there could have been some learning that was still happening in the earlier rounds of the experiment. And we could still also analyze this deeper. Just charting things, we thought that visually there were things that we could look at with regard to learning as well. So, key takeaways. Preliminary results basically show that there is potential for a forward market to improve electricity market outcomes. Preliminary results do show this, as you've seen. Players committed a greater share of their capacity in the forward market, so there'd be quite some activity happening in the forward market. But we need to examine the difference in offers between dominant and non-dominant players to truly understand what's driving this. And very interestingly, the 5-period lock-in forward market had the lowest clearing prices. And so there is something for us to really take a look at in terms of market design. What could we do and what could we see if we look deeper at more granular level data, which we'll try to do over the succeeding weeks to understand what is happening with this treatment and why it's producing consistently the lowest clearing prices. I'll end there and looking forward to comments, questions, insights from the rest of you, and thank you very much.
Okay. All right. So thank you very much to all speakers. So at this point, we will entertain questions from the audience. But before that, I'd like to note that we have about 98 participants in Zoom and about 12 to 16 participants on Facebook. So we now are ready to take in questions. So we have questions in the chat box. May I call on Oscar Alvarez from Water Rock EnergyEconomics? Please, can you please ask only one of your questions so that we may give others the chance? I will come back to you later.
Okay, thank you, Dr. Rabago. Okay. Maybe I'll just ask the first question. Because we have seen recent price spikes in the spot imported LNG spot prices, no? So from $2 per million BTU in May 2020, now it's $34, and our team has calculated. Actually, I had a follow-up message to that. When we did this presentation to the Senate and the House committees on energy about LNG legislation, we said that we were able to calculate a threshold of $12 per million BTU, where new and the existing gas plants can be cost competitive for mid-merit and peaking applications, and also where the existing gas plants can be economical for baseload applications. So what measures would you propose so that we can avoid a similar similar impacts such as what we have been experiencing every now and then with petroleum price spikes? Thank you.
Raul or Carl?
You want to go ahead, Dr. Papella?
Can you repeat the question, please? What is this? What recommendations do we have in order to avoid impasse?
Yeah, to insulate consumers from fuel price hikes. I guess that was
that. Now there is a recent, very recent debate on whether the government should insulate consumers from the recent price hikes. One recommendation was the suspension of the oil tax, right?
Excise tax, yeah.
Personally, I oppose the suspension of the oil price tax. We are in the week of the COP26, and we shouldn't be making it easier for people to use oil. Second, we are borrowing very heavily from abroad to meet our expenses, especially with COVID. I think it's not proper that we should continue. Being indebted or giving away revenues in this scenario. And of course, the third is we have given up 640 billion pesos in corporate income tax, and I think we are in a situation where we cannot afford to be making it easier for the consumers to consume more oil. Remember our history with the oil price stabilization fund, where we essentially insulated consumers from price increases, and that destroyed our whole prospect, because all the monies went to subsidy and nothing for good roads. So I'm really against further insulating the consumers. Let the consumers now feel that perhaps they should do their part in the transition by keeping away from and perhaps using public transportation.
Just to add to Professor Fabella's point, I think the principle is if you were to insulate consumers, you would be insulating the most vulnerable household or firms from the price increases. Now, as Dr. Fabella said, this can be achieved by like blanket reduction in taxes or suspension in taxes, which is not recommended due to competing priorities and spending, especially during COVID. Another is like implementing targeted interventions like cash assistance to the most vulnerable household or firms, The problem is the government has a very poor track record. I'm from Fairview. Every time I drive out, I see jeepney drivers begging for assistance, and they were supposed to have the ayuda from government. So, if targeting were perfect and there were no leakages, as well as there's seamless transfer of money to those vulnerable households, then that could work. Yeah, but government should do more, I guess, improve that if they're going to the targeting route.
Thank you.
Okay, thank you, Oscar. Anybody else who has questions? So you may unmute yourself and show yourself and ask your question. Anybody? I see John Mark. John Mark.
Hi, good afternoon, Dr. Rabago.
Yes.
Yes, John Mark Catrice. I'm from the Philippine Electricity Market Corporation. First of all, congratulations to the team. That was quite a good turnout on on this session, I must say. My question actually, questions actually are focused on your study and also the Paulo's presentation. First on the outage study, and if I can just zero in on the independent variables that you use in the survival analysis model. You mentioned about use rate, but it seems that the use rate there is modeled like an availability rate and not as a use rate. I'm also thinking that maybe if that study can be further conducted in the future, a stricter or truer use rate could be used. Like for example, plants that are mainly used in a volatile manner in the WSM could have some effect on their forced outage. So I think plants that are dispatched on a whim, ramping down on a whim, and not really on a stable course, that could also, I think, very well attribute or impact the forced outage performance of plants. Another would be, and you mentioned that you focus on coal plants. Coal plants in the WSM, or at least the ones I know here in the country, actually use different kinds of coal, be it in purchased in Indonesia or from Australia or maybe somewhere in Russia. So coal, the quality of coal is actually one of the I think major drivers of forced outage. A simple analogy would be like in a basketball game, nutrition of players are paramount if you want to maintain their health. So this is like coal is like the nutrition of these coal plants. And for the other one, the earlier one, the usage is more of basketball players who are mainly used on the court will probably have more probability, will have the high probability of forced outage rather than those players who are benched. So I think these two variables are very key in the survival analysis model. If I can now go back, go to the next question, and this is my last question for Paulo. Hi, Paulo. We met a long time ago in PCC. About the model, the results overall is really intuitive and is aligned to the expectations. However, I saw in one of your table in the bottom entry of that table, the comparison of real-time prices. There seems to be some inconsistency in terms of if you can maybe pull out that slide, that for cases of spot and forwards with 5 lock-in periods and also must offer feature, there is a higher tendency for higher prices on the 0 dominant players category rather than in the 1 dominant and 2 dominants. This to me seems to be the counterintuitive portion of the model. And before I let this go, I just want to give a shout out to my game theory professor, Professor Fabella. It's nice hearing you again, sir. Thank you.
Tej, do you want to answer first?
Yeah. Hi, John Mark. Yeah. Sorry, can I just get you to repeat which treatments you were comparing, the 0, 1, and 2 dominant, with the 5-period lock-in?
Yeah,
Is that right?
the bottom entry.
Yes.
It's
Yeah. No, I think it's a very interesting thing to point out as well. It's something that we haven't yet answered ourselves, but there are some expectations. For example, that you might expect prices, obviously, with one or two dominant players to be higher than when there is none. But I guess it also would be down to understanding, or I guess some comparing what the offers were of the dominant players, which I guess unfortunately due to time constraints as well, we're not able to give you comprehensive view of what the offers and earnings were of these dominant players, because it's possible that for example, some undercutting might have been happening between the two dominant players, and so we'd want to understand the offers and then what actually happens when you have the clearing prices. So definitely that's something we'll take a look at, and thank you for pointing it out. I think it's very important.
Thank you, Paul. I'm just really curious. Did you have some varying assumptions on offer behavior within and across those scenarios?
So I think, the typical expectations would be that there would be, so maybe the dictation of how the offers would play out, or sorry, the rounds would play out would be more towards being dictated by the dominant players. But I think it's very difficult to sort of see in the game at a sort of a top level view of how it was happening. So I think at this point, very difficult to answer. I'm not sure if Sir Carl or Mamaha would like to add to that. But at this point, I think what's lacking for us to answer that question is really to look at the actual offers and earnings of the dominant players versus the ones who were not dominant.
Thank you, Paolo.
Thanks, Mark, or John Mark, for those questions. With regards to your comment on use rate, yes, we define use rate as the ratio of dependable versus the installed. But I agree with your observation. But I think our concern is we don't have a way to identify which plants, the one that you are saying, the volatile plants. So maybe we can ask you how to identify those plants in our data. And then with regards to your questions on focusing on coal, we did not really focus on coal per se. We use it as a baseline for our binary indicator of all the technology. So it's just a baseline for that. And in the picture that I showed, I just focuses on coal and natural gas in the interest of time, but we did not really focuses on coal. And with regards to the quality, where we source coal, we can't really use it as part of the analysis because we already proxy it for the type of technology. So that's why we have that variable indicator for the type of technology. But we'll take a look at your suggestion on using volatile plants as the measure of use rate. Thanks for that.
Thank you. Understood, Dr. Rabo. Thank you.
Any other question from the audience? Or I'll come back to Oscar. You have your second question on nat gas. Oscar, are you still there?
Yes, Doc, I'm still here. Actually, my second question is, what do you think would be the ideal percentage of LNG in our energy mix in terms of capacity and generation mix? That will still address the energy trilemma objectives of sustainability, energy security, and affordability, given that the DOE has issued a coal moratorium that will impact about 9.55 gigawatts of coal projects. But we would still have some new coal projects coming in, but we also have these renewable portfolio standards, etc. So in terms of these new policies, what do you think is an optimum participation of LNG in the energy mix?
Okay, optimum or otherwise. The fact is that that 50% of our fuel mix is coal. And we are being asked to reduce the coal mix. The ADB-ATM says that 10 plants will probably have to go, starting with 3 plants providing about 1 gigawatt of power. Now, if coal is to be reduced from 50, let's say coal is to drop to 25% of our fuel mix. Who will supply the 25% lost from coal? Well, I'd say that 12.5% of it should probably be supplied by gas. In other words, gas share should increase from 17 today to perhaps about 30. And renewables will have to supply the other 12.5%, which means everything is now non-traditional. There should be a rise of about of non-trad renewables from 2% around there, from 2% to 15%. In a span of probably 10 to 15 years. And I'm being very generous there. Do we have 10 to 15 years before Armageddon is upon us? We don't know. We don't know that. But
2030 is right around the corner.
mentioned the parameters
Yes.
under which we are making these choices. Our renewables, including non-trad renewables, is about 16%, which is some of the highest already. Our carbon footprint is some of the lowest in the world of the middle and low income countries. And so I think we can take we can be more free to adopt less stringent measures rather than get both coal and gas out altogether. We can raise our carbon footprint will not increase considerably if we raise our natural gas share to 25%. It will not increase considerably. But we do need to, that is probably the easier thing to do, increase our natural gas share to 25%. It is the non-traditional renewables increasing by about 13% to about 13% from where it is today, about 3%, which is really the difficult task. And that is where, as I've mentioned, perhaps a idle rooftop solar PV. I'm a pit bull on this matter. So we should probably make some noise along those lines. Thank you.
Can I add?
Okay.
Dr. Patel's point. So yeah, in a separate study, I did a quick back of the envelope calculation on several scenarios to satisfy demand in 2030, taking into account various technologies. In that paper, we estimated that the share of installed capacity of natural gas can be as low as 23% to as high as, in the business as usual scenario, to as high as like 39%, with availability of LNG either through importation or through indigenous sources. Yeah, but the thing is that high scenario is coupled with ancillary policies like a carbon tax. Okay, so of course you have to balance everything. So trying to increase the utilization of natural gas through those policies like carbon taxes must be weighed against the impact and imposition on household and firms. So if it makes electricity more expensive, you increase the share of natural gas, but consequently you make electricity more expensive. You need to balance that. That is with the carbon tax. So
Okay, let me call, thank you again, Oscar. Let me call Renzi and JCat. Would you like to share the clarification with regards to the registration of electric vehicles? Renzi, JCat?
Yes, ma'am. To answer Sir Raul's question, if electric vehicles should be registered, yes, there was an administrative order released by LTO just this year of May that requires electric motor vehicles to be registered with them. However, there's an exception if the electric vehicle is like a scooter type or the lightweight vehicles, they are exempt from the registration. And also to answer your follow-up question, yes, vehicle specifications are required during the registration. However, this only applies to hybrid EVs because there are some types of EVs that are fully battery operated.
So paano yan? Paano yan, Renzi? Wala nang, kasi pag nag-register ka, engine number ang ginagamit eh. Anong ginagamit instead of that?
I think, sir, that applies only to those type of EVs with engine. The problem is that I don't know if...
So kung pure EV, hindi pwede.
Yes, sir.
Yun ang mabigat. That's what I was going to ask. Kung pure EV siya, hindi siya ma-register. So we cannot do anything.
JCat?
Yes, ma'am. Please proceed.
Okay. JCat, do you have anything to add to that? Meron ka bang ina?
No, ma'am. I just added to Renzi's answer sa chat box, ma'am, about that same administrative order.
Okay. Tej, would you like to share your clarification with regards to the number of players and the type of players that we used in the experiment?
Yes, sige, ma'am. Dr. Fabella was asking about the players and the information set. So yeah, we recruited university students to participate in the online experiment. They knew what the distribution of the trinkets, or this homogeneous good, was. The number of players in their group. They knew the actual demand at that point in the round. And also how the clearing price was going to be determined was explained in an instruction set before them. So they were asked to read and actually to verify that they understood. We also had a short quiz asking them about basically the salient points of the experiment, how things worked essentially. So we would ask them and they had to answer these questions correctly so that it would confirm to us that we could proceed with the experiment, and they read the instruction set.
Okay, unless there are any burning questions, we will end this session today. But before we end, let me now invite everyone to turn on their camera for our photo session at the end of this session. So while you're turning on your camera and fixing your hair, the Philippine Economic Society would like to thank our partners and sponsors. These are the organizations that supported the Philippine Economic Society. You see them on the screen. And as a reminder, PES requests that you accomplish the online evaluation. I gave the link on the chat box. You can only get your certificate of attendance if you accomplish this evaluation form. So now, if everybody is ready, we can have the photo session. Rainier and Bea, who is helping us, will take the photo. Okay, and they will count.
Okay, first frame. Okay, 1, 2, 3. Okay, another one. 1, 2, 3. Okay, last one. 1, 2, 3. Okay, thank you.
All right, so we come to the end of this session. Thank you very much to everyone for being with us. We hope to see you in the other sessions at the PS. There are so many parallel sessions up to 7 o'clock, and also tomorrow there will still be plenary and parallel sessions. Thank you very much and have a good afternoon.
Thank you. There are many sessions, but this is the best.
Bye-bye, everyone.
Bye. See you
Bye-bye.
later.
Thank you, everyone. Have a good rest of your day.
See you tomorrow, Carl.
Yeah.
Salamat, Rainier, Bea.
Thank you, ma'am.